Have you ever wondered why the goods which are manufactured in a factory are exactly similar to each other? Take the example of the chocolates which you buy in the market. If they are of the same company and same flavor, then their taste never differs. This was about the consumer products. On the other hand, how a complex railway or electricity distribution network is managed by the utility companies. The answer to all these questions is SCADA-based systems for industrial automation. So my teammate Sohan Kulkarni and myself Pratik Wang are here before you to explain to you our topic SCADA-based systems. Now let us get introduced to the basic structure of industrial automation to understand more about the SCADA system. This is explained in this automation pyramid. The lower part of the pyramid consists of field devices. These are the devices which are actually installed on site. They do various jobs like monitoring different processes and sending information to the upper part of the pyramid. This is the image of a protection relay which is used as a field device mostly for electrical SCADA. Then comes the layer of PLCs or RTUs. PLC stands for Programmable Logic Controller and RTU stands for Remote Telemetry Unit. These devices provide basic control logic and timing circuits for operation. Also, they do the task of communicating with the high-level systems like SCADA and DCS in the upper part of the pyramid. The picture shows the image of a PLC. Then comes the layer of SCADA or DCS. SCADA stands for Supervisory Control and Data Acquisition and DCS stands for Distributed Control System. What exactly these systems are will be dealt in detail in the further part of the presentation. The upper part of the pyramid consists of high-level systems like ERP and MES. ERP stands for Enterprise Resource Planning and MES stands for Management Execution Services. These services integrate IT systems across the entire organizations and they are used mostly in big companies where other than technical data, various other data has to be considered like the salaries of the workers or the cash balance with the company or the stock import of the company, etc. Let us now move towards the case study of SCADA-based system of Western Railway Suburban Train which we have taken as the case study. The Western Railway Suburban Train Network is the world's most dense network in terms of commuters. Daily, 7.5 million commuters travel by Western Railway trains. The SCADA system is the most vital part of the Western Railway network. The Western Railway network was previously working on 1.5 kV DC but is now subsequently converted to 25 kV AC. The cable known as overhead equipment is used to supply electric power to the local trains through a device called as pantograph. The power is taken from 110 kV line which comes from Tata Electric Corporation and is brought down to 25 kV using 110 kV by 25 kV 30 MVA transformer and then is supplied to the trains. This substation where the job of stepping down of the electric power is done is known as traction substation. As we cannot supply the whole line from Churchgate to Virar by only one substation, so we have total 5 different traction substations to power the trains. Further, there are 16 switching stations known as subsectioning and paralleling post SSP and sectioning and paralleling post SP, which divides the power line into small sectors as shown in the figure. This is done because if a fault occurs at a certain place, only that part of the network can be isolated for repairing and the whole other network will remain unaffected. Suppose a fault occurs at location F, then relay R1 detects the fault as SSP1 and operates CB1. Also, relay R2 provided at SSP2 detects the fault and operates CB2, which totally isolates the line between SSP1 and SSP2. All the protection relays have communication port RS485 which have unique address number by which it can be identified and they communicate with the RCC, that is Remote Control Center, which is located at Bombay Central, which monitors the line from Churchgate to Virar as shown in this figure. Now let us have a look at the control panel images which is situated at Bombay Central. This is the front side of the control panel and over there is the remote telemetry unit which is situated. And this is the back side of the control panel. Now let us move towards the problems with the current railway system. At a certain location within the railway network, there comes a point where two overhead lines overlap each other but are not electrically shorted. This is known as insulated overlap. Whenever a train passes through an insulated overlap, the two supply lines coming from either sides are monumentarily shorted because of the pantograph of the railway. During the normal operations, whenever there is condition of insulated overlap and both the lines of insulated overlap have supply, then the train gets a parallel supply and no problem is encountered. But the problem comes whenever one line has the supply and the next line doesn't have supply. This also really falls into two categories. The first one is the second line does not have supply as certain fault has occurred at the second line. So the circuit breaker has tripped and the second line has a fault which is detected. Whenever the train enters from live to dead section of the insulated overlap, there shall be a heavy flashover, particularly when the pantographs leak and circuit breaker 1 will be triggered and no problem will be encountered as the supply of the train will be cut. But during the second condition, when there is no supply on the second line but the second line has no fault, then what happens? Whenever a train enters from the live to dead section of the insulated overlap, there shall be a heavy flashover, particularly when the pantograph leaves the insulated overlap, which may damage the pantograph due to sparking. The extent of damage is totally dependent upon the intensity of the current drawn by the locomotive, and in most of the cases it leads to burning of the pantograph, because of which the train may stop at a position which can be possibly far from the station. Also, the damage caused is mechanical and takes a considerable time for reparation. But this isn't a problem without a solution. The solution for this problem is using a panto flashover relay, which is designed to identify such situation and trip the feeder circuit connected to the live section of the overlap. So what a panto flashover relay does, it monitors both the lines, line 1 and line 2, and the status of the circuit breakers of both the lines, that is CB1 and CB2. Also, it monitors the potential of both the lines, that is, are those lines on 25 kV potential, and then it decides whether to switch CB1 or CB2. For example, if CB2 is open, yet the line 2 gives a voltage reading of 25 kV, which is monitored by potential transformer, then the panto flashover relay comes to know that though CB1 is open, both the lines are shorted because of the pantograph of the train, and when the train will leave, there will occur a problem. So before the train leaves the insulated overlap section, the panto flashover relay triggers CB1, which opens the circuit breaker 1 and prevents the burning of the pantograph of the railway. But this is not the real problem. The real problem comes when we move towards the Western Railway Suburban SCADA system. This solution of panto flashover relay is not directly suitable in Western Railway network, as each line gets a supply from two different circuit breakers which are physically located at different locations and are far away from each other. For the successful operation of a panto flashover relay, it is necessary to monitor the status of both the circuit breakers and control remotely located circuit breaker. In present condition, it is not practicable to provide a direct cabling between the remote circuit breaker to the location where a panto flashover relay is installed. So the possible solutions are implementing a high-speed as well as efficient communication line, as it will transmit the status of remote circuit breaker to the panto flashover relay and also to the control command center, and also the control command from the panto flashover relay to the remote circuit breaker. And in this way, this situation can be possibly avoided. Thank you. These are our references, and if any question and answers, you may ask.